Hey guys, welcome to this special video. Today we're gonna start with a new class, so get your notebooks ready, get your Maya ready, and make sure you guys are very well prepared to learn all about rigging. I prepared this special course for you guys because I want you guys to get rid of all of that fear that everyone has about rigging. I know rigging is this very daunting thing in the 3D world. No one wants to deal with rigging. It's a really complex subject, but I'm going to try to simplify it, and we're actually going to be doing the same exercise, or we're going to be working on the same model that we did before. We're going to be working on the camera, which is, I think, a very nice model that can teach us all of the necessary things that we need to understand about rigging. So yep, get yourself ready, and I'll see you in the class. Hey guys, Abraham here. I just want to remind you guys that we upload all of our courses to Skillshare. Skillshare is this amazing site where you can access a ton of different content to learn, improve, and grow as an artist. We have all of our courses available to watch and learn from right now in Skillshare. You can check the description down here, and Skillshare is offering 1 free month trial to their premium membership. With this membership, you're going to be able to access all of our courses and watch and learn all of the amazing things that we cover with all of the softwares. So, what are you waiting for? Check Skillshare down here below. Hey guys, welcome to the first part of this special chapter where we're going to be covering the basics of rigging. We're going to be taking a look at some of the basic things that you need to take into account whenever you're rigging something, and how to prepare your models and pretty much understand, get rid of that fear that we have about rigging, and be able to pretty much rig anything we want. So this is the camera that I did a couple of weeks ago for another mini course, which is of course available for everyone for free. And the first thing I need to do is I need to clean this up, because as you can see right now, this is completely dirty. There's a lot of things going on here that I don't like. So I'm going to grab everything here. I'm going to assign a new material, or just the existing Lambert one, so that everything is gray. And I just want to double check to make sure that I remember creating some groups here. Yeah, there we go. So we do have a rotation. Usually when you are going to rig something, you want everything to be in the most standard possible pose as you can. This way, whenever we start placing the joints, which are going to be the main basis of our whole process, we can be sure that everything is going to be just moving in the best possible way. So there's a lot of ways in which we can rig an object. Some people like to have every single piece as a separate element. I personally like to think about this as a sort of groups. So which parts of this camera thing are going to move as a single unit? And I know, for instance, that this antenna, we're going to start from the simple ones, or the most outward facing elements, to the inward facing elements. So this antenna, it would be cool if we could, for instance, have the pivot point down here and move it so that this thing rotated. Right now it's not rotating properly, don't worry. I'm just going to grab these guys right here, I'm going to combine them, and I'm going to change the name to antenna_geo. Very important to use this flag. I like to use geo. Some people like to use mesh or SM for static mesh. There's a lot of ways in which you can name your objects, but I do recommend you name them because it's going to allow you to keep things organized, okay? So this is going to be my antenna. That's the first piece. I'm going to press H actually to hide it because I don't want to see it right now. And now I need to think about the camera. How am I going to be using or moving this camera? For instance, do I want this thing to slide forward and back? Maybe when there's a lot of light, I would like this thing to cover the lens. So that actually looks like a cool movement for my rigging setup. So since I'm not discovering anything underneath this that is making the whole thing look ugly, I think this could be a separate piece. So I'm going to press Shift P, freeze transformation, center P with everything, and let's rename this camera cover. We could even, and I think this is going to be a little bit more advanced, but maybe we could do this. We could even create a little bit of a rig where this thing goes up and then rotates a little bit. Probably has to go way up there and then rotate to cover the camera. Wouldn't that be cool? You guys want me to do that? It's not that difficult, and I think we can do it. So let's keep that idea for now. I'm not sure if we're going to add it just yet, but yeah, let's just keep going. Now, all of these pieces are pretty much going to be moving in the same fashion, right? So I'm going to combine them all. I'm just going to combine every single piece here, because when this thing moves, I want this thing to move as a whole. Of course, it's not going to be moving from this point. It's going to be moving from somewhere else. But I definitely wanted this thing to move as a single unit. And finally, even though we don't have this, it would be cool if we could move this camera up and down in a wall, or in a section of a dungeon or something, like a sci-fi dungeon. So this is going to be the base. I'm going to Shift P this one so that we get this out. This is going to be camera body. And again, let's call this _geo. And this one's also going to be _geo. It's going to be camera anchor underscore geo, and all of these pieces are going to be moving. Now, I don't want to make this element super complex. I actually want to show a little bit of animation as well at the end of this mini series, so that we have like a very nice effect. Maybe we'll even bring this into Unreal to see how it looks once it moves on a game, right? So yeah, this is pretty much it. This is all I want for my element. As you can see, just 4 single pieces. But that doesn't mean, even though we have 4 single pieces, that doesn't mean that we can't add complexity to the rig itself. Now, what is rigging? Like, why do people are so scared about rigging? Well, rigging has to do a lot with hierarchies, connections, and how each thing moves other pieces, right? So let me just check here because we missed something. Did I combine something? Camera body, anchor, antenna. Oh, yeah, okay, my bad. It seems like I combined these 2 pieces. Let's just say mesh separate again. And I'm just gonna grab these 2 guys right here and combine them again. This is going to be, again, antenna underscore geo, like this. And this one, shift P, and this is going to be cover underscore geo. Of course, we will need to like texture this and UV it and everything, but you can actually start rigging your object without having done any sort of like texturing before, and it's perfectly fine. It's perfectly workable. Now, as I was mentioning, rigging is this thing where we want to make connections between objects. And there's a general rule that I like to follow. No, we can create that actually. So that you guys understand how the relationships work, okay? So in an engine or in a game or in any sort of like deployment for this sort of elements, you can't animate groups. You can't animate geometry. I mean, you can. There are ways to do it, but it's not the most optimal way, because if you want to change something, it's a very destructive way of working. So what we do in the 3D world is we're going to have a mesh. I'm going to do like a little cube here. That kind of looks like a nice robot head, so let's use that example. So we're going to have a mesh, and inside that mesh, we are going to have something called a joint. Okay, I'm going to explain what joints are in just a few moments, but we have this joint, and usually, especially inside of Maya, this joint is controlled by a curve. So we're going to have a curve, a Nurbs curve, that is going to move the joint, and the joint, it's going to move the geometry, okay? Now, why do we do this? Well, we utilize joints and curves so that we don't affect the geometry. So we keep the geometry clean, because the geometry sometimes needs to do other things, such as generate hair or particles and things like that. And if the geometry was being animated directly, you could interfere with those processes that needs the geometry to be clean, and that could cause problems. So one way to keep the best control on your geometry and also get more flexibility is to add joints into your object and then control those joints via this thing called a Nurbs curve. Now, usually the joint, okay, so the joint is going to be controlling the mesh through something called a skin, okay? So we're going to have like a virtual skin that's going to move, that's going to connect the joints to the mesh, and wherever the joint moves, the mesh is going to follow thanks to this skin. The curves are going to be usually constrained to the joints, okay? This is an indirect connection that we're going to be using to control the joints. And at the end of the day, the animators, we as the animators, we're going to animate the curves. And since the curves are constrained to the joints, whatever happens to the curve, like if let's say this is your curve and you move this 45 degrees to one side, the joint, since it's connected to the curve, it's also going to move 45 degrees to one side. And since the mesh is connected to the joint, thanks to the skin, this one will also move 45 degrees to the side, okay? So as you can see, this is a chain of events that moves from one point to the next one. And the reason, again, why we use curves connected to joints, connected to the mesh, is to keep a clean process and add more flexibility to the whole element, okay? Now, all of this happens due to something called a transform node. And I need to talk about this one because it's one of the most misunderstood things inside of Maya and inside of any 3D package. Every single object inside of Maya, inside of any 3D package, Blender, 3D Studio Max, whatever, has something called a transformation node, which tells us where the object is, how it is rotated, and how it is scaled. And this information that we have right here is the information that we're going to be modifying to create the animations and the rig. Now, the thing is, there's 2 types of informations that we can have here. First of all, we have something called the local information, and then we have the world information, okay? So if I were to, for instance, rotate this cube sideways and like this, right now, if I press W, you're gonna see that my gizmo is pointing to the Y as an up axis, the X as a side axis, and the C as a front axis. However, the front, the top, and the side of my cube do not match the information on this gizmo. And you can actually see this if I go into the tool settings and I change the orientation to object orientation. Now this is the gizmo. This is called the local rotation axis, or the local transform, okay? It's how the object is located, or how the object is located, rotated, and scaled on its own world, okay? I know it's a little bit difficult to understand. Hopefully the next couple of examples are gonna make it a little bit clearer, but this is how the cube feels as itself, right? It knows that his front-facing face is this one, top-facing face is this one, and right-facing face is this one. So they do not match the current world. However, if I were to freeze the transformations on this object, as you can see now, the local, even though we're in the local axis, it now thinks that it's perfectly aligned to the actual world axis, Y, C, and the X. So that's why whenever we're modeling, at the end of the modeling process, we freeze the transformations to make sure that everything aligns, or at least the gizmos aligns to the world, because that's usually how we model. However, for rigging, we actually want to keep that information in some way to be able to remember where things are pointing. This is going to be very helpful for joints, which we're going to be talking about in the next video. But now we need to understand another concept here. Whenever we create a group, Control G, a group is nothing more than a transform node. It has, again, translation, rotation, and scale, but it does not have a shape, so you cannot select the group. As you can see here, if I try to select the group, I'm actually selecting this sky don't light. Let me delete that one. So I know that the group is there. If I select it, the gizmo is right there, but it has no volume, it has no shape, it has nothing. So I can't select the joints, or the groups. And the other problem that groups have is that when you rotate the group and you freeze the transformation, it also goes back to the world. It realigns itself to the world, which might not be something that we want. And here is where bones or joints come into place. Because if we go into the rigging section and we create one joint, joints are the same thing. They're the exact same thing as a group. They are just a transformation node. They have translation, rotation, and scale. They also have a radius, which is something we can use to change the size of the element. But most importantly, they have something called the joint orient. So I'm going to select the joint, and I'm going to go to display, transform display, local rotation axis. I'm going to be using this one quite a bit, so I'm going to press Control Shift and click to create this button right here so that we can access it, which, by the way, I totally forgot about turning on Cardac so that we can see the keys. There we go. So I'm going to select this guy right here, and if I turn on the local rotation axis, you're going to see that we now see how this bone thinks it is oriented in regards to the world. Now, if I were to rotate this bone without having to go into movement mode, you can see that it shows us where its X, Y, and Z are pointing towards, which is perfect. And here's the kicker. If you grab this guy right here and you freeze the transformations to clean all of this information right here, it remembers its orientation. You go to zeros, except for the translation, I'll explain that later why. But the rotations, which are the most important ones, they go to zeros, but we do not lose, or it does not forget that its Y, it's pointing this way. It does not try to align itself to the world or anything. It keeps pointing to its own direction. And this is thanks to a node that we have inside the joints called the joint orient, where it drops that information, it drops those angles, and it keeps them as a sort of a buffer, kind of like an offset of where it was pointing. So you will have the zeros on your rotations, but you will remember your orientation thanks to this joint orient. And you normally don't use or access this. It's just to save information, but it's super, super, super helpful. So at the end of the day, again, one of the things that I want you guys to remember from this first video, rigging is the process that we're going to be using to connect groups, joints, and geometry so that each of those elements move and control the other ones, and so that we can have more control and flexibility in how we move or manipulate objects inside of the 3D world. Okay? So that's it for this one, guys. In the next one, I'm going to be talking about joints and how to place them and properly orient them for our elements. So hang on tight, and I'll see you back on the next one. Bye-bye. Hey guys, welcome to the next part of our series. Today we're going to continue with the placement of the joints, and we're going to jump right here into our element. So before we start just placing our joints and just moving them randomly, we need to understand, we need to make a plan, how do we want this thing to move? How do we want this thing to behave in regards to the overall operation, right? And one thing we can do is I can just take a print screen here. I'm gonna go back to Krita. I really like the software. It's a free software, by the way, if you guys want to get it. It's like kind of like Photoshop, but a little bit more for illustration. And I'm gonna create a new layer right here. And I need to plan out like how do we want to move this camera? Well, I definitely know that we have to have one sort of joint right here. And this joint is gonna be pushing the camera up and down. Fair enough, right? I don't want this piece to move any other way. Like if I want to rotate the camera, I know that I'm probably going to have a joint right here, which whose main function is going to be to rotate the camera pretty much 360 degrees. Probably not 360 degrees, but like a really nice like big angle. So that would be my second joint. This joint I'm going to call my main joint. Okay, main joint. And this joint is going to be my body joint. Then we definitely want to have a joint for the antenna. I know that's another one. And we want to be able to like move the antenna to the sides. Again, rotate it a little bit in case we want to send some signal or something. And this is of course going to be my antenna joint. And finally, this is where things are going to get a little bit tricky. We have the little cover here for the camera, right? Like this thing that's going to slide forward. But we also saw that it would be quite nice if we could actually rotate it to cover the element, maybe protect it from gunfire or from the elements or something. So even though we don't have the mechanism, like it could be some sort of like magical levitating thing, like sci-fi thing, I definitely need to have one joint right here that's going to push this thing to the sides. And this is going to be called the cover translation. Okay, we're going to have one bone that's going to work as a cover translation device. And I'm going to have a different joint. This might be a little bit difficult to understand right now, but I'll explain as we get there. We're going to have a different joint, which is going to be the cover rotation joint. Why do we want to have these things as separate pieces? Why not keep the same one? Well, because when you rotate an element, right, like if I rotate this bone right here, its translations change, right? So now the translation, instead of going forward, it's going to be going on an angle. So if I want to keep things as clean as possible, sometimes it's better to have a couple of joints to do different functions on a specific part of your character or of your element, like this one. Now, one of the most important things about joints is that they all connect to each other. So eventually, the main joint is going to be the parent, meaning it's going to control whatever happens to the body joint. The body joint is definitely going to be controlling the translation joint of the camera, and also, I would say, the antenna, like this. And then there's probably going to be one extra joint right there that's going to be controlling the rotation of our camera right there, okay? So this is my general like sketch of how I would approach a like rigging process for this camera. You don't need to do this every single time you're preparing a rig. The more experience you get, the easier it is to understand like what you want to do. But it is relatively easy and relatively, I would say, straightforward to do a quick sketch right here. Maybe bounce it off with your art lead if you're working on a project, and make sure you're fulfilling the animation things that you're going to need once you are going to have this thing up. Now, usually there's another bone that we can't place right now, but it's going to be the root joint, which is going to be on the 0, 0, 0. And that root joint is going to be very important because it's going to be the joint that's going to like ground the whole thing to a world. So let's go back to Maya and let's start placing our joints. So I'm going to go into the rigging section. I'm going to turn on, I'm just going to click my rigging option right here. I'm going to create a joint, just hit enter, and I'm going to zero this out. And as I just mentioned, we're going to have a joint that's going to be called the root joint. This one is going to be the root joint. And I'm just going to call this, well, root underscore joint. Now, I am going to show the local rotation axis, and you're going to see that the local rotation axis of this joint are actually aligned perfectly to the world. Y is up, X is left and right, and C is front and back. So perfect. That one's is working great. Now I'm going to go to the right view, and I'm going to start placing the joints that are going to be here on my main camera. I'm going to go to my joint section. I'm going to click once, twice, and 3 times to go into the antenna. Now I'm going to press this little button right here, which is the X-ray joints, and you can see that I've created this thing, which is called a joint chain. Okay, so we have 3 joints. One of them is, or each one of this is connected to the first one that we created. So we create this little nice chain. This is the parent. So if we move this, all of the other ones move. And it's now time that we realize, or we start exploring whether or not these guys are positioned and oriented in the way that we want. And of course, spoiler alert, they're not. So if we take a look at the rotations right now, you're going to see that the rotations are going to be really, really difficult to work with because none of these joints are either positioned or oriented in the way that it will make it easier for an animator to manipulate them. So I'm going to grab all of the joints and I'm going to press Shift P to unparent them. And let's start with the first one. So the first joint, we mentioned that this is a joint that we want to go up and down. However, the up and down of this joint, as you can see, it's like this. It's on a weird angle. We don't want that. So in this case, it would be a good idea to orient this thing to the exact same orientation that we have here on the world. And it's very easy to do. Just grab the joint. Let's go into the rigging section. And on the skeleton section, we can just say Orient Joint. And when there's nothing selected, well, skeleton, Orient Joint. Let's say Orient Joint to world, the first option. I'm going to hit apply. So as you can see now, the orientations and everything on this joint have now been resetted back so that the Y is up, X is left and right, and C is front. So now this joint is going to follow a very simple up and down motion so that we can like slide this camera on like a little track or something and move it around our scene. Okay, so this joint is ready. Now, you might have noticed that this joint has a little bit of information here on the Z and on the Y axis. This is because this translation distance is the distance that this joint is positioned from the origin. So right now, as you can see, we're 3.91 units away from the origin, which is a little bit weird because it feels like more. Oh, it's almost 4. Okay, yeah. So if you want to be like super precise, you can just zero these things out. And that's going to give you like cleaner results as well. So this one positioned at the 4 unit mark, it's perfectly fine. You will not be able to freeze this. Even if you go into polymodeling and try to freeze the transformations, that transformation will never freeze because this object is 4 units away from this other object. So this is the place that it should have. Joints will not freeze their translations, and it's fine. That's part of the whole process. Now, I'm going to grab this guy, and I'm going to parent it. I'm just going to hit Shift and P to parent it down here to this object. And what we're going to do, of course, is going to rename this, and we're going to call this support joint. There we go. So now this support joint will eventually move this whole piece up and down, like this. Now, this one. This is another piece that I want my animators to be able to animate really quickly. And I know that this whole piece, this whole camera body, it's going to rotate on this sort of like y-axis. But which is going to be the pivot point? Well, it's definitely going to be this one right here, right? Which is the center of the cylindrical mass. So what I want to do is I'm actually going to move the pivot point of this object with my V key. I'm going to move it down here to the base of the element. So I'm just pressing B, and I'm going to move it right there. And as you can see, that one is exactly where it's supposed to be. And then I actually want to move the pivot point up to roughly the center of the object, like right there. And it would be amazing if I could make sure that this movement right here is completely aligned with this movement right here, which right now it's not. Like if I select this one and rotate on the y-axis, we get the movement that we're looking for. But if I select this guy and I rotate on the y-axis, we're not getting the movement that we're looking for. So there's a very cool constraint, and this is a trick that that we like take a look quite a bit throughout the courses. This is a trick that allows us to align this joint to match perfectly or exactly to the rotation or the current location of the pivot point of the object that we want. So you're going to select the object and then select the joint, and you're going to go into Constraint, Orient Constraint, and make sure Maintain Offset is off. You're going to hit Apply. And as you can see, the joint is going to rotate itself to the exact same rotation that the pivot point of the object has, but it's not in the exact place. How can we avoid that? Well, instead of using an Orient constraint, let's use a parent constraint, which matches the transformation and the rotation of the object. And if we hit apply right here, boom. The joint jumps to where the pivot point of the object is, and it orients itself so that it matches exactly the way that the joint is positioned. So now the only bad thing is that we get this joint constraint information node, or it's this connection, which is deleted. We don't need it right now. We just use that constraint to get this thing to where it's supposed to be, and now that it's there, we don't need it anymore. Let's call this camera body underscore joint. And there we go. We freeze the transformations, very important. We freeze the transformations so that we don't have any information here on the zeros. These are perfectly fine. We're not going to mess with those ones. And we just grab this guy and we parent it down here. A lot of people freak out when they see the bones going through the geometry. Remember, we're not going to see the bones ever. Not in renders, not in gameplays. We're never going to see the bones. So it really doesn't matter where the bones are crossing as long as the deformation and the objects that you're manipulating work the way that you want. Now, we're going to do something very similar here. I'm going to grab this guy, and I'm going to move the pivot point with D and V to that point right there. And that's a perfect point, actually, to have the bone, like that vertex right there, because that's the point where this thing is going to be rotating. So again, grab the object, grab the joint, and we're going to say skeleton, and we're gonna do a what's the words? Orient constraint, parent constraint. Now the joint is properly oriented to the world. Y is up, X is left and right, C is forward, and we are exactly in the point where this thing is going to be moving the antenna. We delete the constraint, we don't need it anymore, and we just rename this antenna underscore joint. And of course, we can just middle mouse and drag into the camera body, and now these things are together. So if we move this camera body, or if we rotate this, the antenna is going to rotate with it as well, eventually. Okay? So hopefully everything is fine until this point. And now we're going to go for the complex ones, which are this guys right here. So I'm going to go into the rigging section. I'm going to create one new bone, and I'm immediately going to duplicate it. So now we have 2 bones right here. So I know that this piece, let's center its pivot point, by the way. I know that I want this piece to move forward. And the center position, it's a really nice position to be able to do this, to be able to move this to the position that we want, right? So I'm going to grab just one of the bones, well, the object, the bone, and I'm going to say again, constraint, parent constraint. Delete the constraint, and this is going to be camera, cover, translation, underscore joint. And as you guys might imagine, we're going to be moving this thing. Now, here's where things are going to get a little bit more interesting. Ugh. There's a cockroach near my place. It's horrible. There's been a lot of rains over here in the last couple of days, so cockroaches are just like moving everywhere. Okay, so so this thing is gonna move. Now, I know that when this thing moves, like let's say to about there, this is the position where I would like to rotate so that the cover like just nicely fits on top of the element. So technically, this guy will live in the exact same place as this guy, right? In the exact same place. So the only thing I need to do is I can grab one of the joints, grab the other one, and say constraint, parent constraint. So now we have 2 joints that share the exact same position. And again, the only reason why I want to keep them as separate pieces is because maybe I just want to have this thing like move forward, and I don't want to tilt the whole thing. I just want to do like half a tilt, but I don't want this thing to tilt the whole thing. So it's just, again, to get more flexibility. So let's delete this thing right here, the constraint, and this is going to be called camera cover rotation. Okay? So again, this is another sort of control that we're gonna have for our elements, okay? And yeah, that's pretty much it. Now, which one is gonna control which, right? Like, this is very important. We need to understand which of these 2 joints are gonna be like actually skinned to the whole thing. Now, which is most important, the rotation or the translation? And the answer is the rotation, because that's gonna be the last one that we're gonna move. So technically, what we wanna do is the rotation bone is going to move the translation bone, okay? So if the rotation is up here and we do this rotation like this, the translation, okay, the translation bone should be like this. It should rotate as well so that we can push up and down the little thing that we have right here, okay? Now that I'm saying that out loud, we might not even need 2 of them. Let's give this a quick go. Let me check. So I'm just going to do a quick test right here. I'm going to grab this guy and just P. So now technically, or wait. Let's grab, this is parent, or this guy is going to be parented to the translation. There we go. So technically, if we grab the translation and we push it forward, that's what we want, and then we're going to rotate it. Okay, yeah, we can work with this. Probably like move it like this. Okay. Yeah, so in this case, that means that we only need one joint. I thought it was going to be a little bit more complex, but no, it's not going to be as complex as I thought. So just one joint. The translation joint should be more than enough. This is also going to make it a little bit easier for you guys as well. So again, just phrase transformation. Make sure that the names are properly placed, and this one goes onto the camera body. And this is our nice little rig right here. We have the antenna, we have the body, and everything is ready to just start moving. So I'm going to stop the video right here, guys, and in the next one, we're going to take a look at how to first of all, we're going to skin this thing. We're going to create a nice bind skin so that we can move the whole geometry with the joints. So hang on tight, and I'll see you back on the next one. Bye-bye. Hey guys, welcome back to the next part of our series. Today we're going to continue with the skinning process of our camera. Make sure to save often just to make sure that you're not like losing anything. Yeah, we're just going to start with the skinning. So the first thing we need to understand about skinning is that we can have something called multiple clusters, okay? So right now, as you can see, we have 4 objects on our geometry. And technically, we could skin this as separate objects. However, for performance, solutions or just to keep things working as smooth as possible, the best thing is to try and keep everything as a single geometry. So I'm going to grab all of these pieces and I'm actually going to combine them into a single geometry. I'm going to delete the history, so this is just camera body geo. And now we're going to do the actual bind. So how does the bind work? Well, we need to tell Maya that these joints right here are going to move specific parts of the object. And the easiest way to do that is select the joints that you are going to be using to move the object, select the object. As you can see, I'm not selecting the root joint because we're not doing any sort of rigging to that root joint. We don't want that root joint to move anything. And we're going to go to skin and just hit bind skin. This will automatically create the bind skin, and if you move the main body like this one, you're gonna see things are working fine. But if you move one of this, you're gonna see like the whole geometry like deform and do like weird stuff. And that's because by default, the bind skin that we have here is trying to do this sort of like smooth bind where things are gonna move the way like normal skin would. However, this is a mechanical thing, and we are not able to work in that way. So the only thing we need to do now is we need to fix that skin. We need to check how this skinning is affecting our joints and fix it so that this joint, for instance, only moves the antenna, because right now, as you can see, it's moving a lot of things. So I'm going to show you a very, very quick process. This only works for hard surface stuff. So it might not work for characters, but it's a really, really cool and easy way to do it. We're going to select the geometry and we're going to go skin, and we're going to go into this paint skin weights tool. Just going to double click and double click here on the tool. And this is the paint skin weight tools. It shows us how each joint is influencing different parts of our model. Right now I have this thing turned on, which is the use color ramp option that allows me to see colors or gradients. So if I go to the antenna, as you can see, the antenna does have a nice influence on the antenna itself, but it also has a lot of influence everywhere else. So we're just going to use, if you've ever used paint with the little like bucket tool that just fills everything, we're going to do something similar. I'm going to go into my options right here, and I'm going to say replace. And I'm going to replace everything with a value of 0. And I'm going to say flood. So now I pretty much told Maya, I don't want the antenna joint to have any influence anywhere. Fine. That's okay, says Maya. But how are you going to move this thing now? Well, there's a couple of ways. First, we can go into replace and go with the value of 1 and literally just paint the weights on the antenna. Just start painting until everything turns completely white. And that's the signal that Maya is going to have to know, oh, okay, you want all of these pieces to be totally moved only by the antenna joint. However, this can get a little bit tricky, especially because we have a lot of pieces. So one trick that I like to use is I like to go into the select option, double click the vertices, shift double click to select all of the vertices on the island like that, and then go back to paint and just say flood. And since we have those selected, it's only going to float. Oh my god. It's only going to float those like antenna elements. And as you can see now, this joint only moves the antenna, and it moves it in the exact same way as we were expecting this rotation to be working. So now my antenna is perfectly working right here. Cool. Now, how can we make this thing move other pieces? Well, again, select the object, go into paint mode. Let's go to the camera cover, for instance. And again, we're going to place the value all the way to 0. Flood, so that there's no value. Going to select, let's select the cover, and we're gonna say again paint and flood this to 1, and that's it. So now this guy right here only modifies the cover, and we can push the cover forward and then rotate this when we need to, like that. So the animators will definitely know that they need to push this, at least in this case it's 3.6 units so that it can rotate. But yeah, that gives them the flexibility. We can also push this out. We can even like levitate it. Like there's a lot of things that animators could be able to do with this, like just extra cover piece. But the important part is that now our skinning is working properly for that joint, and it's only moving that piece. Now the next one's going to be a little bit tricky, so I'm going to make it easier for you guys. We're just going to go to the main bone right here, to the support joint. And let's go into, well, let's select this guy and double click. There we go. So we go to the support joint. I'm also going to say like flood with a value of 0, like this. So all of the weight has gone somewhere else. Usually not places that I don't want to, but we'll see that in just a second. And now we're going to select. And again, since all of these points are in the same geometry, when we modeled this, everything was a single block, we can very easily just flood this thing like this. And now we check the body of the camera, since all of these points had nowhere else to go because all of the other pieces were already painted. As you can see, I'm not going to have to like complicate this too much and go into each specific piece and select everything. Everything's already white. So I know that if I grab this guy and rotate, everything's going to rotate the way I would expect this to rotate. And same thing with this one. If I move this thing up and down, this thing is going to move up and down the way I would expect this thing to be moving. And yeah, that's pretty much it. Like with this done, our elements are ready to go into the next stage, which is going to be the controllers. Now, a quick test, of course, is just go to each of the joints and make sure that they are moving the way that you want them to move. However, there's a couple of things that we can do, but I think this is going to be a little bit better if we do it in the curve section. So I'm actually just going to Control S to save this again, to make sure that we are saving every single step of the process. And I'm going to stop the video right here. We're going to go now into the controller setup. So hang on tight, and I'll see you back on the next one. Bye-bye. Hey guys, welcome back to the next part of our series. Today we're going to start with the controller setup. So we're going to start adding the controllers that are the ones that the animators are going to be using the most. And there's of course a lot of ways to do it. I'm just going to keep it simple right now because I don't want to overcomplicate things. Again, as I mentioned, I want you guys to get rid of that fear of rigging and start working on stuff like this so that you can get some amazing stuff into Unreal Engine and see how easy it is and start like trying or experimenting with more complex stuff. So I'm just going to go to the curves surfaces option right here, and we're just going to start creating some circle elements. So I'm going to create one NURB circle. I'm just going to make this thing a little bit bigger, and I'm going to freeze the transformation. So let me create the freeze transformation button. Modify freeze transformation. There we go. So we can freeze this one right here. Cool. And this is going to be called my root control. Okay. Important. Root control. That's fine. We're going to create another circle, and we're going to move the pivot point of this guy to the center of the bone, like that. And since I want this to look a little bit cooler and to make it seem, or to make it easier for animators to know what this thing is doing, I'm going to rotate this to the side. I'm going to push it over here. And I'm going to isolate the object. I'm going to go into curves. Let's go into modeling, curves, rebuild curve. I'm going to rebuild this with like 24 sections. Hit apply. So now if I go right click and I go into control vertices, you're going to see that we have a lot of points. Now why am I doing this? Because I can grab like all of these guys, just push them together, and then grab like this guy, this guy, this guy, and this guy, push them up, and then grab this guy, push them up again, grab these two guys, push them up, and I've created this sort of like little nice arrow thing, right? So yeah, that's pretty much it. Now I can scale this thing or keep it close. It really doesn't matter. Again, it has more to do with how animators are going to be animating this thing. One thing that might be useful though, because right now if I go into the side view, I'm not going to see anything. So since this thing is probably going to be animated in the, what's the word? In two sections, I think I can just duplicate this thing to create this sort of like cross section. And let's see if we can combine these curves. Let's try to attach them and see if it works. No, it doesn't work. Unfortunately, curves are one of those things that are a little bit difficult to work with. So that's fine. I'm just going to leave it on the side view. I think the side view is a little bit more descriptive than anything else. So I'm just going to keep it here on the side view. And that's it. Just freeze transformation so that the origins, as you can see, the rotation axis of the curve is exactly the same as the one here. So if I push the curve up, eventually this joint is going to go up as well. And there we go. Now we're going to create another circle. We're going to, again, with V, snap it to this other joint right there. That's a circular option, so I'm just going to keep it like this. And again, just freeze transformation. I'm going to grab this guy right here, or let's grab one more circle. Control D. Let's move it all the way up here to the other joint. I'm going to rotate this around. And this one, we're also going to freeze transformation. So that when we rotate this on the x-axis, it's also going to match the rotation of the bone itself. And I'm going to grab these little arrows that I did over here. I'm going to Control D, move these guys up. And if we go here, as you can see, they do match the local orientation of these things. Like the C-axis is the one that we're going to be pushing. However, one thing that I definitely want to do, here's a nice little trick. I'm going to grab all of the control vertex. I'm going to push them up. I'm going to rotate the control vertex to one side so that even though we move the curve in the control vertices, we did not change the pivot point. So this thing can move in the same way, and it can rotate in the same way, and it's just going to keep everything under control. Now, not only do we need to do this, we need to, of course, rename this. So let's call this support_control. This is going to be camera body_control. This is going to be, what's that? Oh, it's an extra one. This is the antenna control. And finally, this is the cover control. There we go. So all of our controls are ready, but they're not properly parented. We need to mimic the exact same parenting that we have here, because right now we know that if I grab, for instance, the support element and I move this up and down, everything else moves. But if I grab the support control and I move it up and down, nothing else moves, because nothing is parented in the same way that we have right here. So we need to mimic this exact same thing. So for instance, that means that the antenna and the cover are going to be parented to the camera control. The camera control is going to be parented to the support control, and the support control is going to be parented to the root control. And as you can see, the chain or the tree of hierarchy that we have right here on the joints is the exact same hierarchy that we have here on the controllers. That means that our elements are ready to now be connected thanks to something called a constraint. So one of the ways, or one of the things that my students get wrong all the time, is they don't understand why constraints are so important in rigging. These things that we have right here, these curves and these bones, are connected to each other thanks to something that I like to call a direct connection. So each of them is parented, and it's the son or the father of the other piece. However, an object can only have one father, even though it can have multiple sons here inside of Maya. That means that I can't parent these guys to the bones, because the moment I start parenting things into the bones, we're gonna break the chain of the bones, or we're gonna break the chains of the curves. And here again is where constraints come into play, because constraints are these connections. I like to call them non-physical connections, because they can connect two elements that are not in the same chain. Okay, so let's think about this. We want this curve to control this bone, right? What kind of action do we want this curve to have? Well, we only want to push this thing up and down. That's the only movement that we're going to be inheriting towards this bone, right? That means that the only kind of constraint that we need is a point constraint, because we only want to connect the translations of the curve to the translations of the bone. Now, for constraints, the connections are a little bit different in the order. Usually when you parent something, you select the child first and then the parent. In constraints, you select it the other way around. And the way that I like to remember it is by calling them a driver and driven. Who drives and who is driven by, right? So who drives? The curve. We want the curve to be the driver. So we select the curve, we select the joint, and we do a point constraint. Now, what happened there? The joint jumped to the location of this guy. We don't want that to happen in this case. So I'm going to go into point, and I'm going to select maintain offset just for this one. So this one, I'm select this one, I select the joint, and again, I hit apply. So this will keep the distance. It will keep sure that the movements and everything are the same. And now if I move this curve up, as you can see, the joint moves up. And of course, the whole other chain of joints that are connected to that specific one will move up as well. Now, let's go to the next joint. Let's think about what the next controller is going to do. For the next controller, this controller, what is it that I want to do? Do I want to move the camera up and down? No. Do I want to scale the camera? No. I only want to rotate it. I only want to rotate it from left to right. So I'm going to select the curve, I'm going to select the joint, and I'm going to say Orient Constraint, because the Orient Constraint will only connect the rotations of the object. And if I hit Orient, as you can see, things are working exactly the same. But now if I select this curve and I move it, you can see that the whole camera moves, which is what I expect. Finally, I am going to grab the antenna. I'm going to grab this one as well. And I also want to do an Orient Constraint, because the only thing I want to do is I want to be able to move this curve and rotate the little bone there for the antenna. Now for this one, this is where the tricky part is gonna happen, because we want this curve to both move the object and orient it so that we can use this thing to cover the whole thing. So I'm gonna select this guy right here, select the little joint, and I'm gonna say parent constraint, because parent will connect both translation and rotation of the object. Okay. Now if I grab this curve and I move it forward, you can see that, oh, nice. We can push it all the way over here, and then we can rotate it as well to cover the whole camera. So we get a very, very nice effect for the whole thing. Now, we're not going to delete these constraints, of course. We need those constraints for everything to work properly, but we do want to be able to kind of like limit how much influence our animators can do, because one of the things that I was taught when I was learning rigging is that animators will break everything. If you give them the tools to animate a channel, they will animate it to get the best possible result. But sometimes you don't want that. So for instance, I don't want the animators to be able to rotate this thing around. That's not what I want. I only want them to be able to move this. So what am I going to do? I'm going to go to the main curve right here, and I'm going to select all of the elements except for the translation in the y-axis, and I'm going to hit right click and lock and hide selected. It's going to lock and hide the elements, as the name implies, and now the animator will only be able to animate this thing going up and down. So we're going to limit how much control they have over our objects. For this one, for instance, we might say, hey, you know what? I only want to animate, of course, Y, and I only want to do minus 90 and 90 degrees. After that, I just want the camera to stop, that the wall would be really close, so it really doesn't need to go any further, right? So how can we do that? Well, first, we select everything except for rotation in Y, right-click and say lock and hide selected, and there we go. And now, the thing that we need to do is we need to create some limits. And limits are a way in which we can control how far we can push or rotate or move any sort of transform. So I'm going to press Control A to go into the attribute editor, and we're going to go here to the component control. And on the limit information, we can go rotation limit Y, and we just write down minus 90, and the maximum is going to be 90. So now, if I try to push this curve more than 90, it will just stop. It will just limit the information all the way to that point. Technically, you can also change this into like other values, but I think minus 90 and 90 are perfectly fine. And that's it. That way, the animator will only be able to rotate this controller right here, and it will only be able to rotate it to this position, so minus 90 and 90. A lot of control. That looks very nice. We can do the exact same thing for the antenna. The only thing is the antenna has the X rotation, so we can go 90 and probably minus 90. I think that works as well. So again, just select everything except for the rotation in X. Right-click, and we're going to say lock and hide selected. There we go. Oh, my bad. I actually did. I'm serious that it's it's a mistake, but it's a good way so that I can show you. I accidentally hit everything. So how do we get it back? Well, don't worry. We're gonna have to go into Windows, and we're gonna go General Editors, and we're gonna go to the where is it? To the Attribute Editor. No, not the Attribute Editor. Sorry, Windows, General Editors, and it's this Channel Control. There we go. So we select the little curve right here. And you're going to see that we have two elements, keyable and locked. So right now we have this non-keyable hidden, and the only one we want to recover is the rotation in X. So we just go into rotation X, and we move it to the keyable space right there. And on the lock section, we grab the rotation X, and we just move it to non-locked. And that's it. We recovered the element. So don't forget about that one, because it's a very common mistake that people will lock and hide everything. Just again, Windows, General Editors, and it's Channel Control. Okay? So Channel Control, and this is where everything lives. So there we go. So now we grab this guy, again, Control A, and we limit the information to minus 90 and 90. And that's going to allow us to rotate this thing only in this direction. Now here's where the fun's going to happen as well with this one, because we can definitely control and make sure that the animators can't move this thing like back. Now I do want the animators to be able to move this back. Of course, they will need to also like calibrate the antenna a little bit, probably like rotate it so that it's not like touching it. But I don't want this to go like extremely back. So probably like this. How much? That's like 4 units. I think 4 units in this case is good. So I'm going to go here, and on the translation on the C axis, I'm going to say current translation is set to 5.1. That's really weird. Okay, that's fine. So the max amount of translation that we're going to have back here is going to be at, let's say, 3. So let's turn this on, and let's set this to 3. There we go. Let's put this back to, oh. And then we're going to push this forward. Wait a second. Let me go back there. Did I forget? It seems like I forgot to freeze transformations on this one right here. So if that happens, don't worry. I'm going to select this guy right here, and I'm going to destroy the parent constraint that we have. Let's make sure to freeze the transformation. It's really weird that I forgot to do that, but there we go. Freeze transformations. Now we select this guys again, and we say constraint and parent. And there we go. Now this one is clean. It should be clean. That was the original mistake. So now, again, we can go here. And we know that this one's going to be C, translation C, and rotation X. Those are the ones that are going to leave. So everything else is not. So translation C, rotation X are going to survive. And we lock and hide everything else. We go to the transform limits. And on the C movement, we're going to move this thing minus 1.5. So the translation limit is going to be minus 1.5. And the point at which this thing is going to go forward is probably going to be about there. Yep, so that it covers everything. So that's 2.5. So let's bring this back to 0. Turn the positive and say 2.5. So now if I push it, it will only push all the way there. And then when we rotate, the rotation is, of course, going to be minus 90, sorry, it's going to be 90. So we do want to have a maximum amount of rotation set to 90. And that's it. So the animator won't be able to push it, or shouldn't be able to push it. The minimum is going to be 0. There we go. shouldn't be able to push it back. It will only be able to push it forward to cover the camera like element. And that's it. So now there we go. We zero this out, and our rig is pretty much done. So now if we were to animate this thing, we would be able to do this thing and then this thing, very like calculated. We would be able to grab this thing and again just move the element over here, and grab this thing and move it like this, grab this thing and move it up and down, and of course the root is going to control the whole thing. One last thing we need to do, we need to grab the root bone, grab this guy and do a constraint parent constraint, so that wherever this thing moves, everything else moves. And yeah, that's pretty much it. At this point, you can grab all of your curves and just zero everything out. Make sure that everything's set to 0 so that we are super clean. I'm going to save this, of course, and we are done with our rigging process. So as I've mentioned, I do want to show you guys how all of this like comes together inside of an engine. So I'm going to be doing a very quick animation, just a looping idle animation if you wish. And then we're going to bring that animation into Unreal so that we can see it in real time in the game. Of course, we could animate and do a lot of other stuff, but I'll probably leave that one for another time. So hang on tight and I'll see you back on the next one when we do a quick animation. Hey guys, welcome back to the next part of our series. Today we're going to do a quick animation here for the camera, but I want to show you the proper way to do everything. So as you can see here, we have the roots, we have the camera, and we have the root control. I'm going to grab everything. I'm just going to Control G. I'm going to call this group camera rig. And I'm going to save the scene. As you can see, this scene is saved as camera rig. And I'm going to open a new scene. You'll never, ever want to work on the original scene of your rig, because if you break that rig and if you're using that rig anywhere else, it's going to break everywhere. So whenever you're working with a rig, you usually want to do something called a reference. So I'm going to go into File, Create Reference, and we're just going to reference that file right there. So it's pretty much the same thing. The only difference is that this guy right here is not the original. So if anything happens to this one, we're not going to be breaking the original. And if we change the original, if we add textures, or if we add like more models, or we change the skin or something, everything that we do here is going to be updated to the new version that we created. Okay, so that's super handy for the whole thing. And yeah, so what we're gonna do is we're gonna start animating, and I want to create a very simple like idle animation. I want this thing to go up and down, and I want this thing to move like from left to right, use the cover piece, and then just like go back. Okay, so let's keep this thing like 10 seconds. I think 10 seconds is a good number, so I'm gonna say 240 frames. Usually in Maya, we animate in 24 frames increments, so 1 second is 24 frames. I'm gonna grab this little arrow right here. I'm gonna press S, and then at the frame 120, I'm gonna move this thing up. Let's say 10 units, seems about right. Hit S again, and then go to frame 240 and bring this thing back down. So now if we take a look, this is what we have. Up. Oh, did I forget to... Oh, let me turn on auto keyframe. There we go. So this thing goes up and down, up and down, up and down. However, this is going super fast. This is Maya not like calibrating the time properly. Very easy fix. Right click here and say playback speed real time. So now when we do this animation, the camera is going to be going up. And once it hit 120 frames, it's going to go all the way down. Very simple, right? Now, while that is happening, I want the camera to be doing something as well. So in this case, I actually want the camera to start right here on this like 180 degrees. So I'm going to start frame 0. By frame 120, when this thing goes up, I want this thing to go to the other side. And when it goes down, it's going to go all the way back. So now, when we play the animation, this is what we're going to have. The camera is going to go up. It's going to take a peak to the other side. And then it's going to go down. And it's going in like this very mechanical way, which is fine because it's supposed to be a mechanical piece of just like elements, right? So what I'm gonna do here is now I want to create a different loop. So I want this animation. This is not the proper way to do animation for games, by the way. This is just like to showcase the whole thing. But I'm gonna grab this piece right here, and let's add a little bit of movement as well. So I'm gonna hit S, and then on frame 60, let's push it back a little bit, and then on frame 180, let's push it forward, and then frame 340, let's bring it back to position. We kind of want to make sure that everything goes back to the same, like the frame 0 and frame 240 should be the exact same. So we're gonna have this thing going back, and going forward, and then going back. So it's just a little bit of an extra loop right there. Now what we can do to add a little bit more like excitement to the whole thing, maybe when the camera is like off, let's say this is the camera being off, it will have its covered, like completely covering it, right? So again, frame S, we're gonna do this. Let's push this forward and let's rotate it. So the camera is gonna be like this. And in very few frames, let's say like in 40 frames, we're gonna bring the cover back. And then in another like 60 or 20 frames, we're gonna bring this thing back like this. Okay, so what's happening here is we start here, we move like this, and then we move back. Now here, I definitely want this thing to be still like on the front like this so that we don't get any overlaps. So this thing opens, slides back, checks the surrounding areas, and then once it's going like back to the beginning, we're gonna do the exact same thing but in the opposite way. So it's 60 frames, so that will be in frame 180. We're gonna hit S, and then in 20 frames, so the frame 200, we're gonna push this forward, and then by frame 240, we're gonna bring this thing all the way back. Okay, so we're creating something called a loop because this animation will repeat itself. So we're gonna do this. It scans the area, and then after a little bit of like time, it just goes back. Cool. So what if we want to add like a couple of extra loops over here? Like maybe once it hits the top point, like here, we want this thing to move to one side, the other, like 2 times, and then we go back and close it. That when you close it, that's going to be the opportunity for like the let's say the hero of the story or of the character to go across, right? How can we do that? Well, first of all, we need to find which is the movement that we want to keep. So in this case, it's this one, 150. So let's say we're going to increase this twice. So we're going to say, or actually not twice, let's do 3 times the time. So 240 times 3, I suck at math, so 720, there we go. So we're going to say 720, there we go. I'm going to select all of the curves. So this one, this one, this one, and this one. And this 240 frame, like all of these guys, the return of the elements, that's 180. I'm going to push them all the way to the back here. There we go. So now, technically, this thing goes up with the cover. It stays here at the 220. And then the same thing happens, but it just takes a long time to do so. So what I'm going to do here is I'm going to go to a frame 120, this one right here, the upper thing. And I'm actually going to middle mouse and drag this all the way to the end line, which that would be 720 minus 120. That would be 600. So right there, I'm going to hit S. So what this is doing, it's holding this position right here. So we're staying at 120, and then we don't move, and then we go back, okay? Now, we don't want to go back at this position yet. So right here on the twist, we have from 0 to 120, we go to this side, right? And then in 200 or 120 more frames, like frame 240, we want this thing to go to the other side to scan the area, and then frame 360, we want to go back over here to the other side. This is why snapping the elements is super useful. And then frame, that would be 360, 480. No, sorry. Again, I suck at math. Yes, 480. So in frame 480, we'll go again to the other side. And then in frame 560, or sorry, 600, we go back to the other side. And this should leave us with enough time to go back and close the camera again, like this. Cool? So now if we check this again, this thing like opens up, scans the area, stays there, does a couple of scans. That's going to be one scan, and then there's going to be another scan, and it's going to do one more, and then at the final scan, when it goes back from that last final scan, we're going to be able to bring this back into like its hiding position. There we go. So it goes into hiding, and the cover plate goes in. Now there's a little bit of an issue there. You saw the slide. There's like an overlap. So let's take a look at what's happening there. So let's grab this guy right here. And what's happening is we are rotating while we're not finished sliding. So here on frame 660, I'm gonna go to 680, and I'm gonna go here, and I'm just gonna key selected the rotation so that the rotation does not start until we fully deploy that shield, and then we move this thing. And there we go. Now, I don't want the animation to immediately start after this, so I'm actually going to go to frame, let's say 800. Let's give enough time to the player. And I'm going to just grab all of the curves right here. It could be any of the curves. Again, just like all of these guys right here. And I'm gonna copy them to frame 800. So now we have 80 frames, which is like 3 or 4 seconds, which is a lot of time for the player to move past the camera. And then after this is done, like after the camera has been resting for a little bit, it's gonna start with the animation again. So if you think about a game like Metal Gear Solid or things like that, this could be a little animation that we could have there on the game itself, right? And yeah, that's pretty much it. I just need to fix the antenna right here because we only have this animation. So from frame 0 to frame 60, the antenna goes back. And then it very slowly but surely comes back to the front, and then it goes back. I think it's fine. I mean, we can go to frame, let's say, I don't know, like 200. Doesn't even need to be exact right now. And just like move this thing forward. And then let's add like another movement over there. And then let's add like a slow movement forward. And then another movement over there. We can keep this a little bit more organic, like no need to be so precise. And then it's just gonna go down. And just go back to the origin. And there we go. Our animation is ready. If we take a look, you can see the camera just like moving up, again scanning the area. The little antenna is just like doing its movement, a little animation here and there, just to add just an extra movement there. Again, you can be as precise or as random as you want, depending on what the art direction is. But this one looks really, really nice. I like it. So now let's just export it. Let's just export this thing so that we can work with this properly. So first, let's save this. I'm going to hit Control S, and I'm going to save this as camera animation. And here's how we're going to export this. I'm actually going to open the camera rig first. And I'm going to select all of the joints. I'm going to select all by type joints and the geometry. And by selecting both of them, I'm just going to hit Export Selection. And we're going to export this into our Assets folder. I'm going to create a new folder called Camera. And here in the camera, we're going to save this as Camera Rig. Just like that. Now here you can see that we're actually exporting animation, and it says that we're going to bake animation, but we don't have any animation. This is the original rig, so I'm just going to turn this off and just hit Export Selection. It says that the skin definition is a little bit different. It's going to try to do other types of note. That's fine. These are just warnings. Shouldn't be that much of a problem. And now that we have this, we can actually go into the animation itself. Let's save that real quick. And do the same thing, but for the animation, here's the fun part. We actually don't need to export the geometry. The geometry's already been exported on the other file. So here, we just need to say, select, all by type, joints. And we just export the joint information. So we say File, Export Selection, and here we are gonna make the animation, and it's gonna be from frame 1 to frame 800. Actually, we don't need frame 800. We can go from 799, but that's fine. And we're just gonna call this Camera Loop Animation, and hit Export. And there we go. All of the information should have been baked there. Now I'm going to stop the video right here, guys. And in the next one, we're going to jump into Unreal and see if all of this works properly. And we're approaching, well, the end of this course. So hang on tight, and I'll see you back on the next one. Bye-bye. Hey guys, welcome to this next video. We're gonna go now into Unreal Engine, and we're gonna do a little bit of an implementation. So I have this level right here, which we've been using as this sort of, oh wow, this actually, you guys are seeing a little bit of another project that I'm working on. It's looking pretty cool, right? But no, this is not what I wanted to show you. Actually, let me just delete everything here. There we go. So I'm just gonna add here a model. I'm just gonna add a basic shape, just a cube. Let's export this, or make this thing a little bit bigger. There we go. Just a basic floor for a character to be able to walk on. There we go. Now let's add another shape. This is going to be a cube shape. Again, again here, basic or shape, just a cube shape. There we go. And this one's going to be like a wall. So let's make this a little bit bigger. And there we go. Let's keep it right here. I wanna have it on the shadow side of things. So now if we hit play, oh, cancel. Let me go to here. Does this work? Oh, okay, it's trying to do something weird. What is it doing? Here, selected viewport. There we go. So now, as you can see, we are here inside of the game, and we can see the whole thing. So let me show you real quick how do we import the camera. If you've never used Unreal before, then this might be a little bit over the top. But don't worry, I'm just going to try to make this as easy as possible. So if you want to give it a shot, just download Unreal and get it to, like, just import a level, and you should be fine. So I'm going to create a little folder here. It's going to be called camera, camera test. And here inside of the camera, I'm going to right click and I'm going to import to, and we're going to navigate to our project real quick here. So here, assets, camera, and we're going to import first the rig. We're going to hit open, and it will immediately detect that this is an FBX like skeletal mesh. You can see that it says that it's going to be a skeletal mesh. Since there's no skeleton that is currently assigned to this mesh, it's going to create a new skeleton. I'm just going to say import, and it's going to create 3 different things. It's going to, well, actually 4. It's going to create the material. It's going to create the rig, it's going to create a physics asset, and this is the actual element, the skeletal mesh that we want. So technically, if I were to drag and drop this thing into the scene, as you can see, that's the camera. It's super small because the scale was a little bit off, but that's fine. We can just make this bigger. Like if we multiply this by 10, well, let's lock this thing and just multiply this by 10. It's a little bit more like closer to the actual size that I would expect from a camera. And we can place this wherever we want, like right about there. Cool. So like that's the way to import a mesh. Now, of course, this doesn't have UVs or anything, but it's there. It's on the scene and it's working. Now, to import the animation, here's the fun part. I'm just going to import again, and I'm going to select the camera loop animation. And now when I import it, it's going to detect that the skeleton that this animation has already matches a skeleton that's currently inside of my project, which is the camera one. So it will automatically link it to that specific place. And I'm just going to hit import. And as you can see, we're not importing anything else but the animation. No more nodes, it's just this animation sequence. And if I double click the animation sequence, you're gonna see that the sequence is right there. The whole thing is working perfectly fine. Now, I don't wanna leave you guys with just this thing. I actually wanna do a little bit of an extra work. So I'm gonna show you a very basic programming here inside of Unreal. Here's what I'm going to do. I'm going to create a blueprint class. Right click and create a blueprint class. It's going to be an actual blueprint class. I'm going to call this BP for blueprint camera. And now that we have this one, I'm just going to double click and we're going to start building our little programming right here. Let me make the camera a little bit slower so we can see what's happening. Over here, I'm going to add a component. It's going to be a skeletal mesh right here. And this is going to be called the camera. And over here on the right, I'm going to select the camera that's on my menu, which is this one right here. I definitely want to scale this one as well because it's a little bit too small. So that's a little bit better, 10. And now what I want to do is I actually want to add a light to this guy. So I'm going to add a spotlight. So I'm going to look for spotlight. There we go. And this spotlight is going to be, of course, right on the lens of the camera. Let's rotate this. I'm going to turn on my rotation here, snap, so we can snap this. We're going to rotate this 9 degrees. I think the cone angle is a little bit too wide, so let's make this a little bit shorter, something like this. And distance-wise, I think it's fine. Distance-wise seems to be working fine. So now if we compile this, what's going to happen is we're going to have this blueprint that has this camera. And if this camera points to the ground, as you can see, we're going to have a point light. I'm not seeing the light as much. I'm not sure if it's inside the object. Let's go real quick here. Oh, not here, sorry. To the blueprint real quick. Oh, it seems like it's inside, so let's push it out. There we go. So it's going to leave right there. Let's compile this again. And now let's see if we actually... There we go. So now you can see the spotlight on the ground. Cool. Now, of course, we don't want that yet. Let's go back to the BP, to the blueprint. And I'm going to go to my camera options. And if we go here to the camera options, we can actually select which animation we want to use. And we can select a animation blueprint or just an animation asset, which is the one that we want. And we're going to select, of course, the camera loop animation. As you can see, it's set to looping. So it's going to loop, it's going to move that, and it's just going to move it up and down. The only problem is, as you can see, the light remains down here. Even though it is parented to the camera, it's remaining right here. And I don't like that. So what I'm going to do is I'm going to create this parent socket, and I'm going to parent it to the camera body joint. So now, as you can see, when this thing moves, the whole joint is going to move, but it's moving in a weird way. So let me stop this right here. I'm going to go back. I'm going to remove that socket, and let's select the camera, and let's stop the animation for just 1 second. There we go. So before we do the animation, I'm going to snap it to the socket. So here, selecting the light, I'm going to parent this to the camera body. Now it might move, that's fine. Now we just need to reposition this thing to its like actual place. As you can see, that's pretty good. There we go. Let's change the light color to something like a red. Then that's gonna be fun for like a security camera. And now we can again go back to the camera and turn on the animation asset so that this thing is moving. And now as you can see, the light will always move with the proper direction. Okay, so now we compile. The fun part about this is we can bring this blueprint right here, position it so that it's like on the proper direction. So something like that. Oh, let's make sure it's pointing the right direction. Is that the right direction? Seems like it, right? Cool. So now we hit play. As you can see, this thing is gonna be moving and it's gonna be creating, or it's gonna be projecting the light. Right now, the light's not projecting towards me, but it's there. You can see that the infrared light is there. So if I jump across, the light is actually screening towards me. There's of course other ways to do it. Like if we keep the thing like pointing down, we would see the whole thing like hitting us. Let me do something real quick here. For instance, if I just duplicate this thing around and create like a little room like this. Now if we hit play, of course, in this room, you can see how the light is moving around. Beautiful, right? Pretty cool. And once the animation finishes, the cover is gonna block the light, and thanks to Unreal Engine 5 and this new thing called Lumen, it will actually like close the light very nicely. You'll see how it creates like the little hood, and we won't see the light anymore, and we will see some light being bounced off onto the walls. This is a more advanced against setup, but as you can see, look at that. It just blocks the light, and there's no more light. The light is there, but it's being occluded by the whole thing. Now when it opens again, we're gonna see the whole beam again. And that, my friends, is how you can rig, animate, and implement an asset into your game. And of course, one of the great things about blueprints, which is why they're so powerful, is you can have so many of them. Like you can just add as many blueprints as you want. Like this. And now we have three security cameras doing the whole thing right there. Like all of them are doing their rotations and stuff, and they're just like going from one side to the other. So imagine a game where you have like plenty of these guys, and every time you touch them, you hear like an alarm sound or something. There's so many fun things that you can do here inside of Unreal. But unfortunately, we're gonna have to leave that for another time. If you guys like this, maybe you should leave some comments. Let us know what kind of content you guys want me to create, and I'll be happy to add it into the list of like small premium courses or big premium courses, any of them work. But yeah. Hopefully, guys, after this whole process, you are a little bit less afraid of rigging, and you want to give this a go. Make sure to check for the files if you wanna try it out and you wanna rig it yourself and do the whole process. The files are gonna be like the main mesh of the object is gonna be on the usual place. So yeah, make sure to get it. And thank you very much. That's it for now. I'll see you back on the next course. Bye bye.